Hello everybody, welcome to our final talk of the session, not of the day. There's another dev room in here this afternoon. This is Edward Lewis of ICANN, who is
Hello.
having hardware troubles like all of us all the time.
And eyesight problems. The microphone fell off the clip. And when I look at something that small, it disappears because my age of eyesight is advancing. And then I left my reading glasses in my other jacket.
Edward will be talking about the different ways of minimizing any.
Yes.
Good luck.
Thank you. Thank you. Thank you very much. All right. So this, I guess, this is kind of sort of a pet peeve of mine, and I talked to the authors about it of the document, and they encouraged me to bring this and bring it up. But I'm going to try to make this pet peeve interesting to software developers. That's kind of where I'm going with this. So the title here, in the subtitle, I have the name of a document. It's an RFC from the IETF, came out a little while ago, talking about how to minimize responding to any. I'll talk about why we have this document, a little bit about that, an observation I've made, a measurement based on dealing with this, then trying to find out why I see the results I saw, and then see, is this a good thing or a bad thing for the trend of software development? And of course, I have to mention Bert Huber's camel at the end of this, because everything's about the camel. So the document, why does it exist? The QType any is a feature of the original DNS. It's been around since the start, and it has basically three uses. One's benign, that is, you can use it to get a lot of information about a name if you go to the authoritative server and ask it, and you can get everything that's there. You're kind of like snooping on what the authoritative server is saying about that name, regardless of type. It has everything comes back. It has a problematic use because some people realized they could do that and used it to ask recursive servers the same question, not realizing recursive servers don't get all of the records. So they may not have all of the stuff, and any and all became kind of confused. And that was the first road down to this being a problem. Then finally, it became kind of a malicious use of this, because if you wanted to generate a large volume of traffic for say, a traffic flooding DDoS, you could ask for all the records, any of the records at some name, and get huge massive stuff, especially with DNSSEC, the larger use of names now, and flood victims with lots of traffic. Those are the three probably most obvious ways of seeing this query go from being something that was useful to something that we really wanted to kind of get rid of. And for a while, I was very much I wanted to get rid of this too at one time when I was working in a job that this was in fact impacting us. But when this was written, I was not part of the effort. It had moved on to other folks, and I moved out of that job. But in doing this and saying that we had to get kind of stop using any queries, what do you do instead? How do you say, no, I don't do that anymore in the DS? It doesn't really happen. But there were a few ways to look at this. One was to say, we don't do that, but we don't have that way of doing this. In the DNS, it's kind of funny, because if the DNS you say no to someone's query in a sense of an error, that may make them try again, or even more frequently. In fact, we see if we stop answering queries for reasons, we see traffic come up instead of go down. It goes backwards, because people are trying harder to get the information. We also realized we want to help those that were doing things the old way, backwards compatibility, those that were using the problematic version of this. We want to make them not be pained by this. And so the protocol developers tried to come up with some way to say, no, we're not doing it anymore, that would appease all of the interests that were involved here. And before I go further, the way that says no is that there are in the document, there are three different things that can happen. Instead of sending back everything you have about the name, when you're asked for any is not all, but any is the query, you can send back a subset. Just pick something and just send it back, minimize it coming back. The second thing is to come back with a synthesized hinfo, which in the previous talk, Leo mentioned that was revived by Cloudflare's effort, who happened to be the people participating in this document. They brought that back to life, saying, we'll use the hinfo record to say, this is a minimized any query out there. And the third one was, try to guess what the query wanted. And if you've ever written DNS code, you realize that DNS doesn't give you much information beyond, here's what I'm asking. I don't tell you why. So it's really hard to guess when you're writing code. I don't know, code that can guess is really kind of hard. Sometimes you might have an idea, but not always. Now, I'm not picking on this document because the document actually mentions the points I want to make, and these are verbatim clips from the document. The first one says this mechanism does not signal that an incomplete subset has been coming back. It doesn't tell you that it's minimized it. Number two, it receives hinfo response, but it's not possible to tell us hinfo was synthesized for this purpose. So then again, it's not really that reliable. And in the last one, it says it's possible to guess what initiator wants, but not always. So I could tell here that the authors were not trying to just cut things off, but they really there's no place to go with this. That's great. So to clarify my complaint here is I'm not out to stop limiting the query any. I think it's really kind of not necessary to the protocol. The problem is that I don't like the way this kind of is becoming non-deterministic. You ask a question, you get back an answer, which might be a mystery or might be the response. You can't tell one or the other. And this has happened before. This is a small issue probably, but I see it the same way. We overuse serve fail to mean errors of DNSSEC versus other service failures. And there was the use of the TXT record for everything out there. And if you remember the SPF record having to do with mail protection, that didn't go well. So my little experiment, I run something where I do the any query all the time. I use it to look at the TLD operator, the tops of the TLD zones. And so I know I have an idea what's going to come back. So when I ran this, I run 13,475 queries for this experiment. I don't normally do this, but I asked every name server for every TLD an any query. What did I get back? I got about 250 to 260 no's, UDP, TCP. I tried both of them. But the thing that got me is I got like 9 or 10 different ways they said no in that small sample. That really bugged me. It was a small sample, 9 or 10 different ways. And the absolute numbers here are kind of overcounts because operators do a whole lot of work together. If one operator changed their decision, they might switch 250 responses right away. But to give you a graphical view of this, and I don't really have a good, I got the small crayon set at work, so I don't have a lot of colors. So I did this chart this way. The first chart shows, I asked this many times, I got that many responses. Of course, it's pretty good. These are TLDs out there. In UDP, I get a lot of truncation, which is okay. It's understandable. You truncate large responses in UDP. But of the ones that got through there that were problematic, I got a spread. Don't worry about what they are over there. There's a spread, a lot of colors in that circle over there. And that covers everything, including, if you look through there, there's the hinfo down towards the bottom. That's the special case for the hinfo record. All the other ones that was the one type that was seen there, except for the empty one, of course. That means nothing came back. And I got 10 different ways in UDP. For TCP, same thing, except I don't have any truncation in TCP. And I get back another little color wheel with lots of different variation out there. Again, the fact that the NS one is the biggest part, that only means that somebody does it a lot that way. It doesn't necessarily mean there's a lot more use of NS. So I started drilling into the numbers because at first that was what I thought was interesting to see. But then I said, well, let me figure out why I got this. Why am I getting these numbers? I found that some of the IP addresses out there I asked for different TLDs respond differently. So somehow it's a choice based on either per query or per zone or per something going out there. So I decided to figure out, now, can I find some more patterns here? Well, it turns out that TLD operators out there sometimes don't really hide, they don't want to hide their version. So they actually, version.bind actually works for some of them. And I'm looking at version.bind. Now, that's mostly not a great way to get data, but I got something out of it. And so I looked at and there was like half a dozen implementations that popped up that I could identify. 3 of them appear on this chart. It means 3 of them were minimizing. There's no evidence from the other 3 that they were minimizing. Now, mind you, I have the big 4 up here. So 3 of the big 4, and that's bind, NSD, bind, NSD, NOT, and parity NS. So the big 4 open source implementations I call. 3 of them are minimizing some way, and you can see how it comes out here, where there's empty answers from some of them, not from implementation 1 and 3. They all do NS only, and then there's other types that are spread out there, which I couldn't really explain. So I actually did want to explain this. So I looked at the configuration information, documentation, and from what I could tell, in NSD, there's a refuse any option, and it says what it does here. And on UDP, it would truncate, and for TCP, it works like normal. Default is no. Bind 9.14.6 says that over UDP, it'll pick only one of the RR sets to go out there. It doesn't say anything about TCP in there, so I couldn't tell what was going to happen. I didn't experiment myself. Default is no. And I looked up not power DNS, and I could not find documentation saying how to do it. But I found email through doing searches, web searches, saying that this was just not done. So looking at these big four and how they let you configure this didn't answer the question of, well, how did I have it answered differently per TLD? In fact, this doesn't even match up. I have 3 out of 4 doing this, even though 2 say how, and how they, and the choices just don't line up with this. It's still kind of interesting to me to figure out how this is going on. So I'm a bit baffled by this. I couldn't see evidence that operators were able to make choices that looked like it was intentional in doing this. I didn't see that some operator always answered a certain way. In fact, I was baffled by one particular name server which answered the same way for all but one of the zones it was serving up. I don't know. So I don't know. It's somewhere in the software, somewhere in the operations, it's not quite lined up yet. Why does this bother me? I mean, I really don't care much about the any query. I'll get into that. But in the principles of protocol design, I like determinism. I want to know, query goes out, I should get back a predictable result, or a very definitive signal when it comes back. 2, I have this long-term running relationship with operators, and realizing that we staff the desks with people who have less background over time, just because of growth. And so I want the protocol to be simpler. One time I heard this from somebody, I wish I could have a better support for this statement, but a protocol design should be like a state machine. You have state machines on both ends of the channel, and as you you can transition from state to state based on each message going back and forth, or each signal going back and forth, timeouts or whatever. Should be very deterministic. If I'm on this side and I think the other side is thinking this, and I'm telling them something, I want them to go here in the conversation. I don't want them to actually kind of like, maybe they're over here now, I don't know. Like, it makes it very hard to communicate in a protocol when you have this like random number generator essentially popping up there. Now, granted, DNS is not really good at this, but it's a dream. I'd like to have the protocol be very specific so that both sides know where what each other's thinking going back and forth. Now, how does this apply to my observations here? I guess I didn't bring this slide up earlier. I probably should have. I was asking from this end about information over here. But I know over here, these are Apex. They should have an SOA record. They should have an NS record. If they have DNSSEC, they should have a certain set of records depending on what kind of DNSSEC they have. So I have an expectation on this side of where I should come back. And I'm not seeing that come back, and I can tell it's an error. Think about this in a more generic case where I don't know what this name is. Is it an Apex? Is it not an Apex? I don't know. If I get back one record set, I might think that is all it has. If it's better. So it's a little, this is some uncertainty in my mind here about the way this RFC has recommended coming back with the I don't do the full thing. Now, should I be able to detect and minimize any response? Is a fair question, because I go back and forth. I don't think that this is a critical change to the protocol, but it bothers me that we have this non-deterministic element going on, and I'm going to go past this point right now. Another thing is staff expertise out there. I've seen it where I've wanted my operator to have much simpler tools to use. I want the software they use to be simpler. They don't need to understand the protocol. We can't afford to teach them the protocol anymore. We keep bringing more people in, people turning over. They want to know how to make things work. Are things working out there? This puts pressure on the tool makers to make sure the tooling is there, it's in place, and it's simple. So what are the gaps here? Protocol engineers describe the way software can be written. They like functionality, like to make things do more things. But I find that sometimes they tend to lose sight of what's in operations and what the tool makers have to do. Excuse me, the operators. Operators are interesting because they have a job to do that doesn't matter what they're doing. They have to do a job. They have to make sure things don't fall apart. I met with a group of people who are new operators, came in to run an organization. They know how to do they can operate anything, a bus line, a ticket agency. Now they're running a DNS thing. but they're mystified because the protocol really it wasn't running the way they thought it would go. What this does, a lot of operators will lean on packaged software to do this, defaults and all that. Now, the software developers, and I'm assuming a lot of people in this room are more interested in the software development process, caught in the middle of this. And the Huber's camel talk, if you haven't seen that, this is a link to his saying that what straw is going to break the camel's back when I keep getting demands for more and more features on my DNS software. This is what I'm really concerned that this is doing. This is making this camel getting closer to the edge. So it's a classic DevOps issue, maximize functionality versus minimize downtime. So what do you do about this? This is what my message here is. I want to encourage folks in this room to get involved with the IETF process. I was told that, where were you when this document was being written? I said, well, I was actually there and I kind of got tired of it. But people have to go in there and say, is this implementable? Is backwards compatibility always desirable? Do we have to get rid of some old features and say, it also has got to break because we don't, doesn't matter, shouldn't be there. Can it be implemented? That's what people need to have an eye on that when they go to these organizations that run the protocol development. And that's my basic message here for folks. If you're not doing this, what I fear is we're going to have more DNS flag days at some point. We get rid of features or features conflicting with each other. We need to have more input to the process to make sure that we don't say in this document, we're going to let any be minimized. The response coming back is going to be this. You want to have be like one record. You want to have one thing come back saying, if you see this, stop asking for any more information, assume you're not going to get any, and fall back to whatever you need to get your information. And that's my basic message for this talk here. So I have an email. My email is in the slides if you want to ask me about this. You can ask me now, I guess, too. So I'm done. Thanks.
Thank you. Any questions for Edward? Shane.
Hey, this is Shane. It's not really a question. It's more of a comment.
Sure.
I mean, we all know that you can't really trust any queries for anything. So it's already kind of performance art, right? It's like you go to a play and the writer's trying to say something and the actors are trying to say something, the directors are trying to say something, and you have to interpret what you get back. And it can be enjoyable, but don't treat it as science, and you're all right.
Yeah, so this was part of the conversation I had with the people who wrote the document. For what I've been doing, I have a use for it. It's not about my use for it. My use for it actually that works perfect because I'm asking a specific question of a specific small population. I don't deserve to do that. In fact, my code has for years I had fallback to ask for everything you expect to see there anyway. It's just more efficient. But I mean, I don't think the any query. It's not that I want the any query to survive. Don't get me wrong. I don't want it to survive. I want it to be clearer that you're not doing it. That's what I'm after. That was when this document was being discussed. I first was irritated. The hinfo option was the first one out there, and I thought, well, we don't like to reuse. Create a new record type. Oh, it'll take 20 years for that to roll out, right? This is what I'm after. We want to make sure that we do changes to the protocol so that it's sustainable, so that we, maybe we, because, and I understand the discussion that went on too. Well, what about in the case where someone was relying on it, and we shouldn't take it away from them unnecessarily, so maybe we'll do some, is that worth, I mean, is that something we can keep doing? Because that's part of the straws in the camel, So that's the thing. I think if people here felt strongly enough that it changed, don't fight this one. If a change is coming along in the IETF and it's going to change the code in a way that makes the code blowed up big, go to the IETF and let them know this is not implementable. And that's what I'm asking. So.
Here.
Yeah. Right.
Another question?
Yeah. So I presume in your analysis you used non-recursive queries. What about the recursive ones, and what is the role of a DNS cache server in that respect? Because when I was trying to implement the last version of DJB DNS curve, I also had to take the decision what to do with the any ones. Yeah, so that's did not solve it yet.
Yeah, I mean, That's a good question. I mean, in my work, I always go to the authoritative servers. That's because I'm grafting off a code that does that. I didn't do recursive. But it's a good question. What should a recursive server come back with? And if I told you now, I'd be thinking on top of my feet. But obviously, there are a couple. The problem is, my first reaction was non-imp, non-implemented R code. But if that happens, some folks go into a tizzy about that and keep asking other servers now to see if they do it.
And not is for non-implemented opcodes.
Right.
They say.
Right. Yeah. So, so we maybe that's part of the problem. We don't have the protocol doesn't have enough definitive This is there's zone level errors and there's server level errors, right? The server's not going to respond to you, go somewhere else. But when the zone is out, we need to tell them stop asking. I've seen it melt down so many ways. I mean, it's not uncommon to a lot of people out there. But for recursive service out there, I mean, I just haven't thought. I've never worked in the recursive service field, so I haven't thought of it, to be honest. Yeah. That would actually be part of what is in here, because I think the people who wrote this were thinking as authoritative servers too, come to think of it, because I don't see recursive in there at all. And I do know who they were. They worked with Cloudflare, obviously. And they were trying to solve some problems also beyond the ones I was just putting out there, I suspect, but I'll just leave it at that. So.
Any other questions? Okay, thank you.
Sure.
You want this now?
Don't steal that.
Yeah.
This concludes the DNS dev room. In about 30 minutes, the web performance dev room will start here. I will stick around for a bit. Bet some others will. So if you have any questions, talk to us. Thank you for visiting us.